Yes, hello Arnav, is this audible?
Yes, ma'am.
Alright. Okay, so Aram has also joined. So in the last class, we had completed what is meant by fundamental quantities, what are derived quantities, and now we had started with dimensional analysis. So we had seen dimensional formula. Yes, Aram, is this audible?
Yes, ma'am.
Alright. So these were the fundamental quantities. So this is basic now. These we have discussed a lot of times. Now we are just 2 to 3 class. We'll be focusing on dimensions only. See, this chapter, this unit is divided into two parts. One is your dimensional part, other one is your error analysis part. But before moving on to the error analysis part, you should be completely aware of this dimensions part. That's why we are focusing on dimensions part first. So we had seen that if you have to find out dimensional formula of area, so how will you calculate? It is length multiplied by breadth. It means what? Breadth can be written as the dimension, as in the dimensions of length only. So we can write what? Length multiplied by breadth as length multiplied by length. That gives length square. So we can write it as L square. Similarly, if we have volume, then one more length will be added, means height component will be added. If height's component is getting added, then what do we say? Length multiplied by length multiplied by length. That makes it L to the power 3, L cube, in this manner. Now, whatever power you are getting, we call it as the dimension. If it is M0, L3, T0 in this manner, the way we are getting it for this volume, M to the power 0, time to the power 0. See, 0 means nothing, so you're not considering any dimension. Regarding length, L to the power 3, that becomes your dimension. And then the dimensional formula is what? Whatever we are writing in this square bracket, that is your dimensional formula. And volume is equal to L to the power 3. This becomes what? Your dimensional formula. Clear till here? Any doubts till now, Arnav, Aram?
No, ma'am.
No, ma'am.
All right. So let's do few more questions. We had seen this basic table. So what we'll do today, after giving you one question, what we'll try to do, we'll elaborate this table. Because if you have all the questions written with you, then it will be easier for you to revise only, and that way it will help us in solving the questions as well. So before completing the table, we had seen one question on gravitational force formula. Let us do one more question. The formula I'll give you, this formula is of your second term. So by the time you reach your second term, you'll be able to remember all the formula. But for the time being, I'll give you the formula. It is F is equal to this symbol, this small n symbol with elongated one end of n. This is known as eta. So F is equal to eta A dV over dx. When you will be doing your fluid mechanics, then this will come. Fluid mechanics is in your part 2. Mechanical properties of fluids, that is in your part 2 of NCRT. So there you have this. So F is what? F is basically force, A is area, dV is velocity, change in velocity. So change in velocity or velocity, the dimensional formula will be the same. Dx is thickness, thickness, or you can take it in terms of length only. This is basically the thickness. So these are the dimensions given. You know the dimensions of all these. You have to tell me what will be the dimension of eta. So just try it once. Dimensional formula of this symbol, eta.
Ma'am, is it m to the power 1, l to the power minus 1, and t to the power minus 1?
Yes, correct, perfect. It is m to the power 1, l to the power minus 1, and t to the power minus 1. Let's discuss. Correct, good Arna.
Thank you, ma'am.
So see, f is equal to what? You people are having your summer vacations over there, or your school is going on currently?
School is going on.
School is going on. Arna, what about you?
The school is going on right now, ma'am.
So when do you have your summer vacations? July end?
July 1st week.
July 1st.
All right. Okay. So see, f is equal to what? This is eta a dv over dx. We have to find out whatever is the symbol's dimension formula. See, what is this symbol? What is the meaning of this symbol? When do we use this formula? You have a separate full chapter on it. So that is none of your concern right now. What you have to know, how to find out the dimension if any formula is given to you, be it from your 11th standard, be the formula from your even 12th standard. Even if it is given you, you should be just aware of how to calculate the dimensional formula for the first chapter. As soon as you'll be covering the next chapters, the physics will get tougher. Then you will be able to remember all the formulas by yourself. So even if the question comes, you will know the formula. But by now, you just, for this time, you should remember, if you are calculating this, just multiply force with dx, you're multiplying this term with this term, and divided by adv. This whole will be the formula for this coefficient. Actually, this is the coefficient of viscosity. Viscosity is a term used the way you have frictional force, no, in case of motion in air whenever body is kept. Similarly, frictional force when it acts in water. For that, you have this coefficient. Now, force is what? Force is mass multiplied by acceleration. So that becomes mlt to the power minus 2. This is the dimensional formula of force. Even if you forget the dimensional formula of all these, try to recall. Force is what? Mass into acceleration. Acceleration is what we had done. That's why we are making this table. Right now also, after this question, we'll try to complete the whole table. At least we'll do 30 to 35 physical quantities. So acceleration is what? Velocity by time. Velocity is what? Length by time. So you have L by T. Acceleration becomes L by T square. So force become what? mlt to the power minus 2. ml by T square. Now distance, this is thickness. This can be written as the length. Area we have done. It is the square of length. That is L to the power 2. Velocity is distance divided by time. It means distance divided by time. If time goes on the numerator side, that becomes t to the power minus 1. This is what you have. So see, this becomes what? This is m will be the same, m to the power 1. See, L square can get cancelled from here. This is also L square. This is L square. So this will get cancelled. You have one length remaining in the denominator. When this will go up, the power will get changed. Remember always the power gets reciprocal. The sign gets reciprocal if the denominator and numerators get changed. So L is in the denominator. So this becomes L to the power minus 1. Then what do you have? You have t to the power minus 2. And when this t will go, this will become t to the power plus. Now, final answer is m to the power 1, L to the power minus 1. And 1 minus 2 is what? Minus 1. So this becomes t to the power minus 1. This is your dimensional formula. It's in your subjective exams how you should write. And then you should write in this manner. Because this only we call it the dimensional formula. Otherwise, this will be the dimension only. So you have to write it completely. This will be your dimensional equation, whole complete. All right. So just note it down. All those who have not written, then we'll complete the list. So you'll be getting aware of different formulas that are in your syllabus.
Done.
And what about Aram? Done?
Yes, ma'am.
All right, now let's complete the list. So what will happen with the help of this list? Firstly, we are solving it together. So you will be getting more practice on this dimensional formula, how to write the dimensions. And otherwise, what will happen? Questions will come from this list only. So it's better if you prepare this whole table. 7 we have done, if you remember. 7, hopefully, yes, 7 we have done. So at least remember the formula of these till these 7. Rest of them we are discussing it. Most probably you will be provided with the formula. If not, then I'm writing the formula as well. So we have physical quantity, then the formula of it, then the dimensional formula. And let's write the SI unit also. So our SI unit will also get revised because SI unit will also be used throughout. So 7 quantities we have done. This is the 8th one. Now let's come in terms of rotation. All those things that we have studied were for linear translatory motion, acceleration, distance. Now, what if it comes in terms of rotation? So one, you have it as angular displacement. See, angular displacement is basically what the formula is. If I say this is a circle I have, and I have taken 2 points. Let's say this is A point, this is B point. This is the length of the arc, this portion. This portion is the length of the arc. Here, the arc is subtending an angle, that is theta, and this will be the radius of it. If it's an arc, if we are talking about angular displacement means what? The amount of angle that a particular body has covered, the tilt in the angle that it has occurred. Now, angular displacement's formula is what? This is the length of the arc. Length of arc means this L divided by the radius of the circle or the arc, whatever you have, divided by the radius of arc. So see, dimensional formula will be what? Length's dimensional formula is L, capital L, divided by, what will I write for radius? Which dimension? M, L, T, or none of them? Radius. Try to think it from this SI unit of radius. How do you write it? In terms of length, you should write in terms of time.
Length, ma'am.
Length, enough. Perfect. It would be in terms of length only. How do you write radius? 3 meters of a circle. The radius of the circle is 3 meter. You're using length. So radius will also be in terms of length. So see, what are we getting? Length and length is getting cancelled. We are getting L to the power 0. It means this is a dimensionless quantity. It has no dimension. This is a dimensionless quantity. So there is no dimension of angle, and neither there is no dimension for any angular displacement. But remember, this is that quantity which has no dimensions, but it has SI unit, which is radian. So angle is that quantity. You can get it in your objective questions as well. Angle is that quantity which has no dimensions. As you can see, length divided by radius, we are getting no dimension. It is a dimensionless quantity, but it's not a unitless quantity. You have a unit as radian. All right. Okay, so now you first try, both of you try it for angular velocity. Angular displacement I have done. Calculate. You have this kind of table in your NCRT as well. So angular velocity, this was represented by theta. This is represented by the symbol. It looks like W, we call it omega. So the formula is angular displacement divided by time.
Ma'am, can you just go a little up for a second?
Yes, yes. So both of you just text me quickly what will be the dimension of it and the SI unit. Aram, SI unit is definitely correct. Just check the dimensions that you have written. Arnav, it is meter per second is for normal velocity, linear velocity. It's angular velocity. Whatever is the SI unit of angular displacement. See, let's
Sorry,
discuss
ma'am.
it.
Ma'am, I've just written
You have just
instead of that.
swapped it.
Yeah, yeah.
Yes, then that's correct. Then that's correct. Yes, I was also thinking the same. Because it will be, see, angular displacement is what? Angular displacement is a unitless quantity. L is 0. Time has unit. So it will be what? It will be simply t to the power minus 1, means m to the power 0, l to the power 0, t to the power minus 1. Regarding the SI unit, see, radian is the SI unit of displacement divided by times SI unit is seconds. So this becomes radian per second. All right, if you write it meter, then meter is what? It is for linear velocity. Okay, so angular displacement, similar, it's the rotational analog of displacement. That becomes angular displacement. For velocity, you have angular velocity. Similarly, for acceleration, you have angular acceleration. So try it for that. Angular acceleration. This is represented through this symbol. It looks like a cross. We call it alpha. This symbol alpha. So it will be what? It will be angular velocity by time. Now tell me both of it. Dimensional formula as well as the SI unit. This is also easy. So you people will be able to do it. Aram, ML will have any dimension, or were you writing 0? See, angular velocity was what? Angular velocity was t to the power minus 1 only. Divided by, you have another time with you. So when this time will go in the numerator, that will become again -1. So t to the power -1, t to the power -1. That is what? This is t to the power -2. And this is what radian per second was already there for velocity. This was already there for angular velocity. You're dividing it by time again. So this becomes radian per second square. So yes, Iram, your SI unit was also correct. All right, so note it down. Other quantity that you have in rotation that you will be studying is moment of inertia. Inertia you must have heard of in your lower classes as well. Inertia, there is a law of inertia as well. So you have moment of inertia. This is also in your rotational portion only. Moment of inertia. All these are rotational quantities. Linear quantities we had discussed in the previous class. So this is represented through this capital I symbol. See, the formula is what? This is basically mr square. M is the mass, r is the radius or the distance which you can see. So quickly tell what will its dimension and the SI unit will be. Dimensional formula as well as the SI unit. See, this is very easy. It will be ml square, kg meter square. All right, correct, Iram. See, mass is what? Mass is m only. Length square, you don't have any factor of time. So this will be the answer, t to the power 0. And mass SI unit is what? Kg. And this SI unit of length, this is meter. So this is kg meter square. Arnav, can you tell me what will be the CGS unit of moment of inertia?
Can you repeat, ma'am?
What will be the CGS unit of moment of inertia? This is the SI unit, kg meter square.
No.
We had done CGS unit, if you remember. Gram centimeter square. See, the CGS unit of kg, this becomes gram. This is CGS. And for meter, it is centimeter. All right, for time, it will be the same, seconds. I think we had done SI unit and CGS unit. Yes, here we had done. So see, distance CGS unit is what? This is centimeter. For mass, you have gram. All right. So whatever you have the SI units or CGS unit, you can relate it with this. Okay, moment of inertia is done. One more quantity. I think you have done this. No, this is new to you. Torque. Torque is basically whatever force you have studied. Force in case of linear motion. In rotation, we call it as torque. This is represented through the symbol tau. This is known as tau. So the formula is R cross F. Cross product, dot product you will be studying, but right now you can take in terms of multiplication. R getting multiplied by F. So R is the radius, means the distance. F is the force. So this is also easy, that I'll help you with it. See, R is what? R is length. Force is what we have studied, mass multiplied by acceleration. So what will happen? Just length of square of length is occurring. This is ml squared t to the power -2, and the SI unit will become Newton for force and meter. Or if you wish to write for CGS, this will be dyne centimeter. Dyne is the CGS unit of force and centimeter is the CGS unit of meter. Okay, so momentum also we had seen in the last class. Momentum was mass multiplied by velocity, ml to the power t minus 1. We have the momentum, mass multiplied by velocity. Now, what if it is in terms of rotation? Then that becomes mass multiplied by angular velocity. So you have angular momentum. The next physical quantity is angular momentum. This is capital L. This is written as R multiplied by the linear momentum that you have. Whatever is the dimension of linear momentum, multiply it with radius, you will get the dimensional formula for it. So tell me the dimensional formula for angular momentum. This is the radius. This is the linear momentum. Linear momentum means the momentum that you have done in the previous class, that momentum. Just check for it.
Ma'am, it's m to the power 1, l to the power 2, and t to the power minus 1.
Yes, perfect. M to the power 1, L to the power 2, T to the power minus 1. Good enough. See, how will we write it? R is what? R is written for length that you have. M to the power 1, L to the power 2, T to the power minus 1. Perfect. Good. So SI unit also, both of you tell me. SI unit. SI unit will take time because I think you have to perform divisions. Okay, let me just discuss it. See, linear momentum was what? Linear momentum was mass multiplied by velocity. M L T to the power minus 1. This was linear momentum. So it will be just the square of it, ml square T to the power minus 1. Regarding the SI unit for radius, this is what? This is meter. For angular momentum, it was kg per meter square. Kg meter per second. So meter gets multiplied. So this becomes
Over
K.
here, it must be meter squared.
Correct. Kg meter square per second. This is how you write. And in terms of CGS unit, if it asks you, then gram centimeter square per second. If you know what is the CGS unit for kg, what is the CGS unit for meter, then it is easy for you to calculate. All right. Now 3 quantities I am discussing that I'll tell you only. 3 quantities that are there in your syllabus. You must have seen in your index one chapter you have as mechanical properties of solids. So in that mechanical properties of solids, you have 3 quantities. One quantity, this is known as stress. So don't copy it down when I'm writing. I'll give you time. I'll write these 3 quantities. I'll explain with you and discuss with you. Then I'll give you time so you can easily write it down. Otherwise, what will happen when I'll be speaking? No, your content will get missed. So when you have a stress, if you remember what was pressure, stress is equal to pressure only. What is actually stress? You will be able to learn it. This is a very easy chapter of your whole 11th standard, mechanical properties of solids. So stress is basically force per unit area. Whatever was the dimension for pressure, whatever was the dimension for your force and pressure, both are for stress, they are same. So force is what? This is force per unit area, this is stress. Now force is dimension, this is mass multiplied by acceleration, mlt to the power minus 2 divided by area. Area is what? L square. So see, L to the power 1 is there, this becomes L to the power minus 2. So L to the power 1, L to the power minus 2. That is L to the power minus 1 only. Or you can say this L will get cancel the square. So the dimensional formula will be m L to the power minus 1, T to the power minus 2. Everything remains same. That was for pressure that you have studied. Whatever is for pressure. For stress, it is the same. So SI unit will be Newton per Newton meter square, which is Newton per meter square, which is also called pascals. Everything that you have studied for stress of pressure, that remains the same for stress. Now other quantity that is new to you, but this quantity is also very easy. This quantity, this is strain. This is actually whatever is the change in configuration. No, for example, change in length, change in volume, change in shape, any change in the configuration divided by what was original. For example, change in length. Let's say change in length divided by what? The original length that you have. Whatever is the change in length divided by the original length that you have. So now see, change in, it can be any dimension. It can be change in volume by original volume. It can be change in angle by original angle, change in length by original length. There are various kinds of strain. You will be studying types of strain as well. So change in length by original length, or whatever is the change in the dimension divided by that same dimension, will it give you any dimension? Both the units will get cancelled. So what will happen? Change in length, if I talk about L to the power 1 divided by original length, so 0. So strain is also a dimensionless quantity. Dimensionless quantity, not dimensional. This is a dimensionless quantity. So dimensionless quantity. And the important thing that you have to remember about strain is that it's a unitless quantity as well. So in your examination, you get questions like this: name a physical quantity which has a unit but no dimension. Angle, no dimension, but it has a unit. Name a physical quantity that has no unit, that has no dimensions, neither dimensions nor unit. Strain, it's a dimensionless quantity, neither it has any dimension nor it has any SI unit. So that quantity is known as strain. Just remember the name of the physical quantity. Then you have modulus of elasticity. Modulus of elasticity. Now elasticity is basically stress divided by strain. Ratio of stress divided by strain. So stress was what? Stress we had seen, this was m L to the power minus 1 T to the power minus 2. And strain was what? Strain was dimensionless, no dimension, m to the power 0, L to the power 0, T to the power 0. So it means dimensional formula of modulus of elasticity, this becomes the same as the dimension of pressure or stress only. That is m L to the power minus 1 T to the power minus 2. And the SI unit is also Newton per meter square, or this is Pascal. All right, so quickly copy down these three quantities. So which chapters are currently going in your school, Arnav, in physics?
Same chapter, ma'am. We're almost about to finish this.
All right. And Aram, what about you?
Same, ma'am. Same chapter.
All right. After noting down all these three, no, just try it for surface tension. So surface tension, this is basically force per unit length. This is easy. At least tell me the dimensional formula after writing down this. Yes, Aram, good, correct.
Ma'am, what is the SI unit of this?
SI unit, see, you only tell me what is the SI unit of force?
kg meter per second.
Force. Kg per meter per second. This is also known as Newton.
Newtons, yeah.
Newton. So this becomes Newton per meter. All right.
Okay.
So for force, you have mL to the power 1, t to the power minus 2. Length is L. So length gets cancelled, and SI, the dimensional formula you get is m t to the power minus 2. See, SI unit of force is Newton divided by SI unit of length. This is meter. One more quantity I'm giving till the time. Okay, this first, let us discuss this one. This is an easier one, wavelength. So wavelength you must have done, I think, in 10th only. In your 10th standards course only, either in 9th or 10th you have wavelength. No, so wavelength is basically the distance between two waves. One wave is formed, whatever is the length of that wave. In definition terms, we can say either the consecutive distance between a crest or a trough. So that distance is known as wavelength. So this is also a form of length only. This is the formula of it. Dimension will be L only, and the SI unit will be meters only, and CGS unit will be centimeters. So wavelength is the same as that of length. Then one more quantity that comes, that is time period. Whenever period terms comes, no, time period, it means an interval. For example, if I say the earth revolves around the sun, so time period becomes 1 year, means the interval that it takes for the earth to move around the sun. So time period is what? This is the time. Ultimately the dimensional formula will be t, SI unit, this will be seconds. Now other quantity that you have is the reciprocal of time period. We call it as frequency. The reciprocal of time period, we call it frequency. So dimensional form, the formula of it is 1 by time. Time period, this frequency is represented through this symbol, nu. We call it nu, this symbol. So nu is equal to 1 by time. So just reciprocal of time, it means t to the power minus 1. Okay, remember the SI unit of frequency. It can be two. Either it can be seconds inverse because it is reciprocal of time. We called second inverse as hertz also. In this manner, hertz. This hertz. All right, it is based on some scientist name. So these are also few very easy dimensions. Then I'll give you one more. Till the time you note it down, I'm giving you. So first note down all these and then solve it. Planck's constant. So energy is equal to, this is Planck's constant h multiplied by this frequency. You tell me what will be the dimensional formula of it. Energy, you know, I've told you energy, work done, all are same. Frequency, I've just told you. So first quickly just note it down and then tell me what will be the dimensional formula of Planck's constant.
Ma'am, it's m to the power 1, L to the power 2, and t to the power minus 1.
Yes, correct. It is m to the power 1, L to the power 2, t to the power minus 1. Both of you are correct. Both of you are correct. See, this is what? It will simply be E divided by H. Planck's constant will be energy divided by H. Energy we had seen, it was m L to the power 2, t to the power minus 2. This was what for energy. Divided by frequency. Frequency is what? Frequency, this is basically t to the power minus 1. So this becomes what? When t will go up, that becomes plus 1. So this is m L to the power 2, t to the power minus 1. Now, energy, the SI unit will be what? For energy, the SI unit is joules and divided by the frequency. Frequency is second inverse. So it will be joules second. If you are asked to write the CGS unit, then that is erg second, because erg is the CGS unit of energy. All right, just wait for 2 minutes. All right. So written till here?
No,
Yes,
ma'am,
ma'am.
just a second.
Okay, just write.
Okay, ma'am, I'm done.
All right. So three quantities are left. Three quantities are left, and we'll move on to questions into a different topic. In this dimension only, how to use dimensions and applications. So applications basically. Two I'm telling you, third one you will tell me. So another other quantities regarding your thermal physics. Thermal physics is included in your second term after your bulk physics means bulk mechanics, fluids and solids. You have thermodynamics, thermal properties. So from there you have temperature. Now temperature, is it a fundamental quantity or is it a derived quantity?
Fundamental.
Fundamental. It's a fundamental quantity. Temperature is represented through the symbol as I've told you, theta. So it's a fundamental quantity. There is no formula of it. Why? Because fundamental quantities cannot be formed with the help of any other quantity. So dimensional formula remains theta to the power 1, or you can write it as Kelvin to the power 1 also. And the SI unit, this is Kelvin, or CGS unit is Celsius. This is the CGS unit. The other quantity that I was telling you is heat energy. So heat energy, this is represented through the symbol delta Q or capital Q also. Only Q is also enough. Now the formula of it is energy. Whatever is that you have studied for energy, that remains the same for heat energy. So it will be what? ml to the power 2 t to the power minus 2. This is for heat energy. SI unit, this is joules, and the CGS unit, this is calorie for heat. Now this quantity you will tell me, the last quantity for today. Specific heat. Then we'll move on to questions. Specific heat is represented through the symbol S. What is specific heat? This is a long topic. Just remember the formula. This says delta Q means the heat energy is equal to mass multiplied by the specific heat multiplied by the change in temperature. This is the change in temperature. This is temperature. This is energy. This is mass. Tell me what will be the dimensional formula for it. First, write down 20.22.23. Then after writing down, then tell me this. Then we'll move on to questions.
Ma'am, is it m to the power 0, L to the power 2, and T to the power minus 1?
Till here it is correct, but something is missing still. You have one more quantity this time, temperature.
Ma'am, Kelvin is also there, right?
Kelvin is also there at the end. Kelvin is also there. See.
Okay.
All right, Arnav.
Yes, ma'am.
Because temperature is a fundamental quantity, so you cannot neglect it. So S is what? From here, this specific heat, this is whatever is the heat energy divided by mass divided by the temperature. Heat energy or energy, that is ml to the power 2 t to the power minus 1. Mass is m. Temperature, this is temperature, not time. Be careful while writing. If you find it better, write it as delta T. So, so as to distinguish between time period, that is capital T, and the temperature. Temperature is what? Kelvin. So mass gets cancelled. M to the power 0 is there. L to the power 2 is there. T to the power minus 2 is there. You have one additional K to the power minus 1. So fundamental quantities can be written. All right. This will be joules for it. Joule divided by mass, it will be kg. For Kelvin, for temperature, you have Kelvin. So this will be joules per kg Kelvin. This is the assignment. So once write it down, let me know when you are done. Then we'll begin with questions on applications of dimension.
Can you go a little up?
Yes.
Done, ma'am.
What about you, Aram? Done?
Yes, ma'am.
All right. So this is enough. If more quantities are required, we'll do it in the next class. But let us move on to some kinds of questions that are very essential. See, let me explain you with the help of a question only. Let's say f is equal to a minus x square divided by b t. From here you have f as the first. I'll explain this question. I'll do it myself. Then the other question I'll give you. So this is force. X is position. Position means length only. T is time. Now, A and B, these are constants. Constants whose dimensions we are not aware of and whose dimensions we have to calculate right now. So you have to calculate dimensions of A and B. Now, regarding the dimension of A and B, before that, we know, let's write the dimensions of F, X, and T. Force, you know, mass multiplied by acceleration. Mass is m, acceleration is L to the power T minus 2. So force is this. Position is length, so that will be L only. Time period, this will be T only. Agreed till here?
Yes, ma'am.
Yeah? All right. Now see, how to solve this? You know the dimension of f, you know the dimension of x, you know the dimension of t. You don't know what are the dimensions of a, you don't know what are the dimensions of b. Remember, if you have any operation with you like addition and subtraction, whatever will be the dimension of one quantity before the operation will be equal to the dimension of the quantity after the operation. It means if you have length minus length. See, reason is what? Reason is basically one quantity can be subtracted from the other one if they have the same dimension. You can multiply different quantities, you can divide different quantities, but you can add or subtract similar quantities only. For example, if I tell you subtract 500 meters from 30 degree. Is this even possible? Just let me know.
No, ma'am.
This is not possible. How can you subtract 500 meters from 30 degree? Had I given you subtract 5 meters from 1000 meters, then you will be able to do 500 is getting subtracted from 1000. It means 1000 minus 500, that gives you 500 only. But if I'm telling you subtract 500 meter from 30 degrees, this is impossible. You will not be able to subtract it 500 meters from 30 degree. Reason this degree, this is angle. 500 meter, this is what? This is length. Subtracting length with angle, this is not possible. It means if the question is giving you a minus x square, it means the dimension of a is equal to the dimension of x square only. If the dimension of a is equal to the dimension of x square, then only this formula is correct. If it's not correct, then it wouldn't have been given you. Otherwise, for example, if I give you some other quantity, this was length. If I say just add 1000 meters to 20 kgs. Can you add 1000 meters to 20 kgs? Is it possible by any chance? Yes or no, class?
No, ma'am.
This is not possible. Subtract adding 1000 kgs to 20,000 meters to 20 kgs. This is not even possible for you. Reason because 1000 meters is the SI unit of length. We are talking about length completely. On the other hand, how can we add mass onto the length? So it means we can add only like terms. If the question is saying a minus x square, question is telling you that a is getting subtracted from x square, it means definitely that whatever will be the dimension of x square is the dimension of a, then only we are able to add or subtract. See, multiply and divide you can do. That's why we have different quantities. If you see in the equations, whatever you have written over here, you have seen equations are getting divided. Different quantities are getting divided. Force is getting divided by area. It is giving you a different quantity stress. So you can divide. Mass multiplying by velocity is giving you momentum. You can multiply. But did you see anywhere I'm adding two quantities or I'm subtracting two quantities and telling you that this is the formula? No, because you cannot add or subtract different quantities. So in this, if it is telling me that a minus x square exists, this simply says the dimensions of a is equal to the dimension of x square. So Arnav, what is the dimension of x square?
Ma'am, it's length L.
X square.
Oh, L square.
L square, correct. L square. For x you have L, so it will be L square. It means dimension of A. This is L square only.
Yes, ma'am.
All right. So one part we have solved. Now, see, F you know, A minus x square you know, T you know. Only B is unknown, no? So we'll be able to write it for B. We'll be able to write it for B. See how? In this formula, F is equal to A minus x square divided by BT. From here, see how can we write it? If I write A or A minus x square, this we are getting this. We know. A minus x square, what will it be? Ultimately, we'll be getting L square only. A minus x square, whatever is the constant's value, we are not concerned with. We know A minus x square, the dimension that we'll get is L square. Force we already know, time we know. What will be B? B will simply be A minus x square divided by force divided by time. So Aram, you tell me, what will I write in place of A minus x square?
A minus L square.
No, not A minus L square. See, that's what I'm wanting to tell you. See, if I say this is 5 meters, all right, and I'm x square is, let's say, 2 meters. Can I subtract 5 meters? Okay, or let it be 5 meters from 2 meters. This is correct. Can I write it in this manner? Is this correct or not? Can I write 5 meter minus 2 meters?
Yes, ma'am.
This is correct. So when I write 5 meters minus 2 meters, this gives me what? This gives me 3 meters. So am I getting 3 meters square or am I getting 3 meter? I'm getting a single meter only, no? What I have done, even if you subtract 5 meter minus 2 meter, you get it as 3 meters only. So you are getting the single unit, meter. Meter minus meter is giving you meter only. So length minus length will give you length only. So if it is L square for both of them, so L square minus L square will give you L square only. I'll write down this again. Let me explain this again. C for A minus X square. Carefully listen. If you have any doubts, you can ask me to repeat n number of times. It's okay. A minus X square you have. If I say 5 meter minus 2 meters, I am getting result what? 3 meter. It means what? When I am subtracting meter from meter, my answer is not 0. It is still meters. 5 meter minus 2 meter is not giving me 0. It is giving me 3 meters. Means I am still getting meters. This means what? Length minus length is still length only, no? 5 meters minus 2 meters is 3 meters. So length minus length is still a length only. This is not a dimensionless quantity. You have dimension of length. Length minus length is giving me length. So dimension of A was what? Dimension of A is L square. All right, let me write it for L square. Minus X square. Dimension of X square is what? Dimension of X square is also L square. So L square minus L square. This won't get cancelled and get me 0. L square minus L square means what? 5 meter square minus 2 meter square. It's like area. This is like I am subtracting 2 meter square. I have a square field. I have a plot of 2 meter square. I'm subtracting 2 meter square from 1 meter square. What will be the answer, Aram? 2 meter square minus 1 meter square.
1 meter square.
1 meter square. I am getting 1 meter square. Means L square minus L square is still giving me L square. So whenever you have addition and subtraction, you consider whatever is the total SI unit. So Arnav, now you tell me, what should I write? This B is A minus X square divided by F divided by T. Instead of A minus X square, what should I write, Arnav?
Ma'am, your voice broke. Can you repeat?
I'm saying instead of A minus X square, what should
Yes,
I
ma'am.
write? What should the dimension that I should write?
Ma'am, it will be length.
Only
L.
length? L?
No. L square.
L square. Aram, you tell me, do you agree with Arnav?
Yes, ma'am.
Any doubts till now? Why are we writing L square? Or it should be L square minus L square or 0? Any doubts till now?
Ma'am, L square will be for A, right? Not B. B will be.
B will be something else that we are calculating. This we are.
Not B.
Yes. This we are calculating. This till here, this is correct. Why A minus X square is L square?
Yes, ma'am.
Aram, what about you? Clear to you?
Yes, ma'am.
All right. Now, since B has no relation with A, as you can see in the formula only that is given to you, F is equal to A minus X square divided by BT. So for B, it is independent. We are calculating something else. Force, we know. Force was M L to the power T minus 2. Time is T. Now there will be something different dimension formula for B. What will this be? m to the power minus 1. This will be L to the power minus, this becomes minus 1, no? So that becomes L to the power 1 plus 1. L to the power 2, L to the power minus 1. This becomes L to the power plus 1. T to the power minus 3 is there. This is T to the power minus 2 is there. And T to the power 1 is there. So this is T to the power minus 1. When it will go up, it becomes, see, this is T to the power minus 2. That becomes T to the power plus 2. This was T to the power plus 1. That becomes T to the power minus 1. So B's formula is what? M to the power minus 1, L, T to the power 1. This is dimensional formula for B. For A, it is L square. Clear?
Yes, ma'am.
Aram?
Yes, ma'am.
All right. So note down this question, then I'll give you a question. How to use this. Start noting it down. I'll scroll slowly. Have you written this portion till here?
No, ma'am, just a second.
Okay, okay, right. Take your time. Done?
Yes, ma'am.
All right. So this question is also similar to the previous one, what you have studied, the how to apply dimensions. So this we'll do together only. You both will tell me how to solve it. See, first I'll brief you with what are your dimensions given. This is not required for you. Don't get into details what is RT. With the help of this only, no, your question will be solved. See, P is pressure. P is pressure. If you remember, just look into your notes. The dimensional formula for pressure, this is mL to the power minus 1, T to the power minus 2. This is for pressure. V, this is volume. Volume is LQ. Then you have again V as volume. RT, these are some constants. These are not even of your use right now. Actually, we have an equation. PV is equal to nRT. This equation you will be studying in physics also and in chemistry also. In chemistry, you will be studying this PV is equal to nRT as well. States of, you have a chapter on this, I think in your first term only. So you have to calculate the dimensions. Calculate the dimensions of A and B again. Now, can any one of you tell me what will be the dimension of B without any calculation? B,
P or B?
B, the constant B. This.
L cube
Meters per second.
minus L cube?
Aram says minus L cube? L to the power minus 3.
Yeah.
L to the power minus 3.
Yeah,
And
because
yes,
yeah,
Aram.
because there's minus B, right? So minus L cube.
No. Just the dimension formula of B. Dimension formula of B. What will be this? Aram.
L cube.
L cube. Arnav, what about you? Yes, Arnav?
Yes, ma'am, it'll be L cube, I
The
think.
reason?
Because volume also has the same dimension, so
Perfect. Good. Correct.
it'll be same for both.
It will be same because volume is, this is both of them are getting subtracted. If volume has the dimensional formula is L cube, then definitely B would also be having the same dimensional formula. Then only, no, both are getting subtracted. Had it be having a different formula, dimensional formula, then this, don't confuse this A and B with the previous A and B this that you have studied. This is a total different question. So dimension of B will be equal to the dimension of volume only. That's why they are able to get subtracted. So dimension of B, this will be simply L cube. All right. Now regarding A, this is also easy. Can anyone tell me the method to calculate for A? Just try, then I'll help you. Any method to calculate it for A? Any idea by looking at the formula?
Ma'am,
Just
it'll be
enough?
the dimensional formula for P plus 1 by dimensional formula for V.
Okay, a little closer. I'll help you. I'll help you. See, what do we have? We have it as the first term as P plus A by V square. Yes, agreed. This is your formula. That
Yes,
is,
ma'am.
this
Yes, ma'am.
is V square. Now see, whatever terms are there between the operations of addition and subtraction. I've told you that whatever the terms are there, they have the same formula. That's why they are getting added or they are getting subtracted. If dimension of pressure is something, let's say dimension of P is there, this will be equal to what? The dimension of this whole term, A by V square. Then only we are able to add A by V square plus P.
Yes,
If
ma'am.
yes or no?
Yes, ma'am.
Dimensional formula for A. This is m to the power 1. Okay, this A. L to the power 5, T to the power minus 1. Not time. I think you made a mistake in time. L to the power 5 is there and M is there. T to the power minus 1. Just check A once again. So see, this will be equal to what? Dimensional formula of A by V square. That's why we are able to add P and this. Yeah, this is correct. Good, Aaron. Correct. So dimensional formula of P is what? Pressure. Dimensional formula of pressure is M L to the power minus 1 T to the power minus 2. This
Yes,
is
ma'am.
equal to dimensional formula of A divided by dimensional formula of V square. Now dimension of A, we don't know, we are calculating it. But what will be the dimensional formula of V square, Arnav?
That'll be m to the power 1, L to the power 1, and T to the power minus 2.
V
Oh,
square,
sorry, volume.
volume.
Lost me. It'll be L cube.
L cube is for V square,
L to the
volume
power
square.
6.
L to the power
L to the
6.
power 9.
L
Ma'am,
to the
9 or
power
6?
6. 6. See, you are correct. L to the power 6.
Because we're cubing.
See, L to the power cube, you are squaring it. So power
Oh,
gets
yes.
multiplied, no? So this will be
Yes, ma'am.
3 multiplied, L to the power 6 only. Now this question is easier. Dimensions of A, just multiply this term by this. Dimensions of A will be what? M L to the power 1 T to the power minus 2 means this term multiplied by L to the power 6. So dimensions of A is M minus 1 plus 6 means 5 only. L to the power 5 T to the power minus 2. Clear?
Yes, ma'am.
So this will be the dimension of A and dimension of B was very easy. All right. So note down this question as well. Last question for today. I'll stop here today. Just note down and just let me know when you have done it.
Ma'am, can you go up? Thank you, ma'am. You can scroll down, ma'am.
Done, ma'am.
Done, ma'am.